Alright. It's been a while. But today we're going to do a review on what now? On trigonometry. Right? So I'll just do a review. I'll run through things that we have done before we come to focus on what now? The aspect of trigonometry I want us to concentrate on today. What I would say trigonometry is? Trigonometry is the study of the relationship between the sides and the angles of what now? Of triangles. The relationship between the sides and the angle of a triangle, of triangles rather. Before now, we have talked about triangles under what? Geometry. We said geometry is the study of what? Shape. Geometry is the study of what? Of shapes. Alright? And then geometry is broadly classified into two: plane shapes and what now? Solid shapes. This is a plane. And this plane is what? It's a rectangle, plane shape. Solid shape simply what now? The shape of what? Of solid. So we have said before now that plane shapes are two-dimensional because they don't have a sense of depth. Two-dimensional. A plane, they are usually part of a solid. So if, for example, I take this, this is solid, and this is a keyboard, right? You see that this face here is plane. This space is also plane. All these spaces are plane. And what kind of shape is this? This one is what now? This is a rectangle. Are you with me? This is a plane what? A plane shape. My focus is going to be on triangle. I'm trying to explain what plane shapes are what now? Are two-dimensional, and solid shapes are what? Three-dimensional. They have a sense of depth. Plane shapes do not have what now? Sense of depth. Simply, the shape of any solid is what now? Is the solid shape. Just like the name is, the shape of a solid is a solid shape, and they are three-dimensional. For those of us who have done science before, okay, I think I have to put myself together. Stress out. Okay. For those who have done science before, that matter, you were told the matter can exist as what now? Solid, liquid, or what now? Organs. And solids have what now? Shapes. Alright? So under plane shapes, we have polygons and what? And cycles. Generally, under plane shapes, we have two classifications. Not like they are the only examples of plane shapes, but these are the what now? Major examples of what? Plane shapes. Polygons are what now? And cycles. And what is a polygon? A polygon is a plane shape that has what now? Three or more straight sides. A plane shape that has three or more straight sides is what? Is a polygon. For example, this has three sides, so this is going to be a triangle, right? This one has what? Four sides. This is going to be what? A quadrilateral. Because all the sides are what? Are made of straight lines. If I had something like this, even if the sides are three, I cannot call this one what? A polygon. Because these sides are straight, but this side is what now? It's curved. You understand what I'm trying to say? So if it's made of plane, a plane shape that all the sides are made of straight lines, right? Is what now? Is a polygon. And the smallest polygon is what? It's a triangle. Triangles are emphasis, that's what brought us here. We know what a cycle is. Triangles, quadrilateral, pentagon, hexagon. Okay. The one with three sides, the triangle, four sides, quadrilateral, five sides, pentagon, six sides, hexagon, seven sides, heptagon, eight sides, octagon, nine sides, nonagon, and 10 sides what now? Decagon. Alright? Then under solid shapes, we have regular shapes and we have what now? Irregular shapes. Most regular shapes are what? Are man-made. They are artificial. Man-made. Because all naturally existing solids are irregular. They don't have a definite pattern. Because anything that exists naturally is usually what now? Irregular. So regular shapes are man-made or artificial. And there are some examples under regular shapes. I gave you the cube, cuboid, cylinder, prism, cone, pyramid, sphere, hemisphere. I'm not going to all of that today. Our emphasis is what now? It's going to be on what? On triangles. Triangles. Triangles is actually a subset of polygons. Polygons subset of plane shapes, and the plane shape is subset of what now? Of geometry. It's just a reminder. Okay, so let us go a little further. One of the things that I will need to explain much later, I will need to explain some of the things we do later, will be what now? Similar shapes. I will talk about similar shapes too in the past, right? What are similar shapes? Two or more shapes are said to be similar if they have the same angle. For example, these ones are what now? This is 90 degrees. This is 90 degrees. 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees. So the angles are the same, not necessarily all of them 90 degrees. And then if this side, let me say this is what now? A and this is B. And this is X and this is Y. If the ratio of corresponding sides are equal, ratio is going to be A over B equal to what? X over Y. If they have the same what? The same angles, and then, or similar angles, what I should use now, similar angles. Okay, let me use this to buttress my point. Look at this, for example. Let me say this is 120 degrees, and this is 60 degrees, for example. And here's what now? 60 degrees, and here's 120 degrees. And here's 120 degrees, and here's 60 degrees. Here's 60 degrees, here's what? 120 degrees. You see that the angles here are exactly the same angles what now? In this way. You know what I'm trying to say? Now, if this side, X over Y, is equal to this side, let me say A over what now? B. If X over Y is equal to what? A over B. Ratio of corresponding sides in this shape, for the two shapes, right? If they are the same, we say that they are what now? They are similar, not equal, similar triangles. Are you with me? They are similar what now? So similar shapes. Let me use this triangle now to buttress my point. Let's say, for example, that this is 30 degrees. Alright? That's 30 degrees, and this is 80 degrees. 80 degrees, and this is 70 degrees. And here I have 30 degrees, and here I have what? 80 degrees. And here's what now? 70 degrees. I get it? If this place is 15 centimeters, and this place is 10 centimeters, are you with me? And this place is what now? This place is 5 centimeters. I'm giving an example now, right? This place is 5 centimeters. What would this place be? These two shapes, obviously, what now? They're what? They're similar. Are they the same? This one is bigger than what now? Than this, but they're similar. That means that what now? X over 5 will be equal to what? 15 over what? Over 10. X over 5 will be equal to 15 over what? Over 10. Are you getting what I'm trying to say? So if I want to find the value of x, x becomes what? 15 times 5 over what? Over 10. And that's going to give me what now? 75 divided by 10, that's 7.5 centimeters. So this place here will be 7.5 centimeters. Because if the two shapes are what now? Are similar, they will have the same what? Angles, 30, 80, 70. 30, 80, 70. And the ratio of their corresponding sides will be what now? The same. Do you get what I'm saying? Ratio of corresponding sides will be what now? The same. Are you with me? Okay. Let's try this. I think there's one more thing to very quickly. Okay. So for trigonometry, right? We have said that trigonometry is the study of what? The relationship between the sides and the angles of what now? Of a triangle, right? We have to ask ourselves, what kind of triangle are we dealing with? And generally, triangles are classified into how many groups? 2 groups. They're classified by sides, and they're classified by what now? Angles. Classified by what? Sides, and classified by what? By angles. So if I'm doing classification by sides, I'll have what? There's the one that none of the sides are equal. That is called what? Scaling. Scaling triangle. No sides are equal. No sides equal. We have what now? Isosceles triangle. Isosceles triangle. 2 sides are what? Are equal. 2 sides are equal. Then we have what now? Equilateral triangle. Equilateral triangle. All the sides are what? Equal. And all the angles are also what now? Equal. Remember that if all the angles are equal, each of the angles will be what? 60, 60. Because sum of angle in triangle is what now? 180. Are you with me? For scaling triangle, no sides equal. So I can have something like this. Here is 5, here is 10, and here is what now? 13 centimeters. This is an example of what? Of a scaling triangle. None of the sides are what? Are equal. Do you understand? However, if for this triangle, I had that here is 5, here is 10, and here is 10. And here is 10. What kind of triangle is this now? Isosceles. Because this side is equal to what now? This side. You get the idea, right? Okay. If all the sides are equal, I have an equilateral what? Triangle. The other classification of triangles based on what? Angles. This is classification based on sides. Classification based on what now? Angles. I will have what? The first one is what? Acute angle triangle. Acute angle triangle. All the angles are less than 90. All angles are what now? Are less than 90. All angles. What am I doing? All the angles are what now? They are acute. Are you with me? All angles are what? Acute. Right angle triangle. One of the angle is what now? 90 degrees. One angle is right. That's 90 degrees, right? This one, all are what? All angles are acute. That's less than 90, right? For acute angle triangles, all angles are acute. Right angle triangle, one angle is what? 90 degrees. Then finally we have what now? Obtuse angle triangle. Obtuse angle triangle, one of the angles is what now? Is obtuse. One of the angles is what now? Obtuse. One angle. So let me give you an example of this quickly. If I give you this, I give you this, and then I give you this. I want you to tell me the one that is right, the one that is, this is 70, this is 70, and this is what, 40, this is 30, this is 60, and this is 90, this is 130, this is 20, and this is what? 30. For this one now, this is triangle A, triangle B, triangle C. Which triangle is an acute angle triangle? Which one? I can't hear it. Which is an acute angle triangle? Why is it A? Because all of them are less than what now? 90 degrees. You get that? Acute angle triangle. B is what? Because what now? One of the angles is what now? 90 degrees. This one is what now? No. Obtuse angle. Obtuse angle. We're talking about angle, right? Obtuse angle because this one is greater than 90 but less than what? 180. Perhaps we have forgotten, right? We get the idea, right? My focus is the right angle triangle. But just for the purpose of a reminder, as far as geometry is concerned, the most important triangle is what now? Is the right angle what? Triangle. The right angle what? Triangle. Now get this. How many of you remember this guy? This will take some. Okay. How many remember this? What's that? Arrow, right? These are types of what? Of angles. A is what? Acute. This is what? Right angle. This is what? Obtuse angle. This is what? Straight. So we have what now? Reflex. An angle at a point, right?
Yes.
Angle at a point or angle about a point. This is to help us remember. If it is right, is what? 90 degrees. If it is straight line or straight angle, is what? 180 degrees. If it is angle about a point, is what now? 360 degrees. Right? What is acute? Acute is less than what? 90. Obtuse is greater than 90, but less than what? 180. Reflex is greater than 180, but less than what? 360. So if I tell you that the angle is 120, where will it fall? Obtuse, right? If I tell you that the angle is 290, where will it fall then? Reflex. If I tell you that the angle is 180 degrees, what is that? Straight line. If I tell you that the angle is 1 degree, where would that be? Acute. It's less than 90. If I tell you that it's 89 degrees, where would it be? Acute. If I tell you that it's 91 degrees, what will it be? 181 degrees, what will it be? Yes. Do you understand? If it's 360 degrees, it's what? An angle about what? Now, 8 points. Now, foundation has been what? Laid. We can start what? Building. The important thing we want to emphasize is that under trigonometry, as far as trigonometry is concerned, we are classifying triangles as right angle triangles and what now? Other what? Triangles. Right angle triangles and other what? Triangles. So if I read this point, we can take it further. Is that okay?
Yeah.